Hello, in this video, we are going to simplify a complex fraction using two different methods. The first method doesn't require learning anything new, but it also takes longer. The second method requires learning something new, but it's faster. Both methods will result in the same answer. For the first method, we are going to start by just looking at the top of the big fraction. You can ignore what's on the bottom for the moment. On the top of the big fraction, we technically have a fraction plus a fraction because 5 can be written as 5 over 1. If we're going to add fractions, we need common denominators. The common denominator between x and 1 is, well, 1x, which is just x. So let's multiply the second fraction by an x on the top and the bottom so that we have common denominators. Since 1x is equal to x, the denominators of the fractions on the top are the same. Since the denominators are the same, that is good, and the denominator is going to stay the same after we add the two fractions. On top, we have 2 plus 5x. We cannot factor anything here, so we are done on the top. Nothing cancels, nothing factors, we are done. Now, temporarily, we are going to ignore the top that we just worked on, and we're just going to look at the bottom now. 25 is technically a fraction. It's 25 over 1. Of the two fractions on the bottom, the common denominator is x squared. So I have to multiply the second fraction by x squared on top and on the bottom. Now that the two fractions have the same denominator, the denominator is going to stay the same, it's x squared, and on top we have 4 minus 25x squared. But wait, we can do more with this 4 minus 25x squared. 4 is really what? It's a 2 times 2. And negative 25x squared is technically a negative 5x times a 5x. This is a difference of squares that we can factor. So the top of the big fraction is going to stay the same. We can't do anything more there. But the top of the fraction on the bottom factors to be two parentheses. The first parentheses is 2 minus 5x, which is multiplied to the second parentheses 2 plus 5x using the difference of squares formula. The denominator stays the same as x squared. Now we have a big fraction. A big fraction means to divide. So we can rewrite this as a division problem. The top fraction is divided by the bottom fraction. To divide fractions, we can use the phrase same, change, flip to help us remember the process. The first fraction stays the same. If you want to put the 2 plus 5x in parentheses to indicate that it is one factor, a thing unto itself, you can do so. Division changes into multiplication, and the second fraction gets flipped, or you take its reciprocal. We are almost done. What is the same that's on the top and the bottom that cancels? Well, a 2 plus 5x is being multiplied and a 2 plus 5x is being divided, so the 2 plus 5x's cancel. Also, on the top, you have x to the second, which is really an x multiplied to itself. And on the bottom, you have 1x. So this x is going to cancel out with one of the x's on top, leaving with just 1x, or x to the first, on top. Finally, to write your answer, the only thing left on top is x. And the only thing left in the denominator is 2 minus 5x. Be careful, do not cancel those x's, because on the bottom, the 5x is being subtracted, and a subtraction and dividing do not cancel. So we simplified this complex fraction using the first method. The first method required that you knew how to add fractions, you knew how to factor, you knew how to divide fractions, same, change, flip. Kind of a lot of work, but it really isn't anything new. Now we're going to do the same question using a different method that ends up being quite a bit faster, but it also requires learning something new. First thing, we have to find the LCD of all four quote-unquote little fractions. Remember that 5 is really 5 over 1, and negative 25 is negative 25 over 1. So looking at all four of the little fractions denominators, what is your common denominator? Well, when you're finding the common denominator, the LCD, you look for which factor has more. This has the most x to the seconds, so your LCD is going to need an x to the second. Technically, it also needs a 1, but 1 times anything won't change anything. So you don't need to write that 1. Now we want to multiply every little fraction by the LCD over 1. So the first fraction gets multiplied by x squared over 1. The second fraction gets multiplied by x squared over 1. The first fraction at the bottom gets multiplied by x squared over 1, as does the second fraction on the bottom. Now let's cancel. For the first fraction multiplication, notice that you have x to the second on top and x on the bottom. The x on the bottom is going to cancel out with one of the x's on top. And then you're left with 2x plus, dividing by 1 doesn't change anything, so this is still 5x squared. Looking at the first multiplication on the bottom of the big fraction, the x squareds will cancel, and you're left with just 4. 4 minus 25x squared. Now, let's factor on the top and on the bottom. On the top, let's factor out a GCF of x. Which leaves you with x times the parentheses of 2 plus 5x. But the denominator, remember that 4 is technically a 2 times a 2, and negative 25 is a negative 5x times a 5x. It's a difference of squares, just like it was the first time we did it in the other method. Factor to get 2 minus 5x times 2 plus 5x. What cancels? Well, the 2 plus 5x's cancel, leaving you with your answer of x over 2 minus 5x. Notice that this was the same answer we had for the first method. Thanks for watching this video. Hope you learned something and have a good day. Bye.